Now that we've covered dimensions and units, we're going to move on to where you can manipulate and change these units to make them useful for day-to-day physics. So the first thing we want to talk about is the metric prefixes. They can change units by order of magnitude. These are the metric prefixes. They are prefixes that you can put before any kind of unit to get a new unit that's orders of magnitude either larger or smaller. For instance, a meter, which is about 3 feet, as I said earlier, when you say kilometer, that means 10 to the third or 1,000 meters. So a kilometer is 1,000 meters. On the other hand, a centimeter, which is 10 to the negative second meters, is 1/100th of a meter. And you can combine these prefixes and terms in any way you want, and you still get the same answer. For instance, it can be kilometer. You can write km, which is the abbreviation for kilometer and the abbreviation for meter. And you can write it as 10 to the third meters. You can write it as 1,000 meters. All of those things mean the same thing. And this is just a way that we can use a very small set of units, and we can get a much broader set of terms that are very useful for expressing things of different scale. For instance, if I want to measure how much I grew in the last year, a centimeter is a much better unit of measure. But if I want to measure the distance from New York to London, a kilometer is a much better unit of measure. Because if we try to measure the first one in meters, we're going to end up with a very, very small decimal that's hard to understand. And if we try to measure the distance from New York to London in meters, we're going to end up with a really large number that's hard to understand. So these prefixes let us scale our units to something more easily understandable. Now, just like numbers, you can divide and multiply by these prefixes and these units to get different terms. For instance, if I wanted to know what's 1,000th of a gigameter, I would say 1 gigameter divided by 1,000 equals 1 trillion, 10 to the 9th, divided by 1,000, 10 to the 3rd, times meters, which equals 10 to the 6th meters, or 1 megameter, which you can also express as 1,000 kilometers. It's worth spending a little time messing around with these units of measurement to make sure you understand this. But the point is, these are just stand-ins for larger numbers to make it easier to talk about and understand what's going on with the physics problems. The other useful thing that you can do with units is you can think of the units as a variable. Just like 10x is the same as 10 times x, we can say that 10 meters is the same as 10 times 1 meter. And a lot of the same rules apply when you're thinking about units and when about variables. For instance, you can only add units of the same type. For instance, 10 meters plus 5 meters is 15 meters. But you can't add 10 meters and 5 seconds. That doesn't equal anything because they're not the same unit. Similarly, if I divide 20 meter seconds, now I don't know what kind of problem would ever give you meter seconds, but if I divide it by 10 meters, I can cancel out the meters just like they're variables, and I end up with 2 seconds. So that's often a very useful trick inside physics problems, is look at the units and treat them just like variables. So you can only add like variables, and when you divide a variable by itself, it just cancels out. And this is going to be very helpful for us next lecture, when we're going to go over dimensional analysis, turning one set of units of measurement into another. For instance, miles to kilometers, or hours into seconds.